Hello, in today's lecture I will tell you how you can create a Matlab script. So you will have to click over here and you will have to open the script. So the title is Untitled 9. So first of all I will create a folder at my desktop. So there is already a script, so I'm going to remove it so that it can easily be uh, one can easily understand. There is a folder on my desktop. The name of that folder is Matlab script. So I have already created a folder, so I'm going to save this empty script over there. So I'm going to define the path, and I'm going to save it as m file. I'm going to save this with m file 1. Now what I'm going to do is I'm going to define the complete script. Whenever you are going to write a comment in the Matlab script, what you will have to do is you will have to write the percentage symbol, and then whatever you write, it doesn't get executed. So there is no result if you execute this script. The comment are not like instruction, these are just the description of the file. So you can write whatever you like over here. Now I'm going to define some variables, but before that I will write a few set of instructions so that all the garbage may be removed while I'm going to execute the file. First of all, I will define a variable x from 0 to 10 with a step size of 1. When I execute it, I see the result that variable x have been created and values stored within the variable x are from 0 to 10. Total number of values are 11. The dimensionality of this vector is 1 multiplied by 11. Now let me show you something over here. When I write x is equal to 0 to 0 0.5 and up to 2, when I write from 0 to 2, what I see is there are three values. The first value is 0, and then the step size is 1, so second value is 1, then the step size is 1 again, so the next value is 2. But when I write it like here 0.5 and then writing 2, so there are 5 values. The first value is 0, then 0.5, then 1, 1.5, 2. You can change the step size whatever you like, so 0 to 0.1 to 2, 3. So there are many values. You can, if you change the step size to a very small value, then there will be a very big huge result. So the Matlab will take a lot of time to execute this instruction, and to display the result it will consume a lot of time. So I'm going to stop it over here, and let me include some more instruction within the script. I'm going to write another variable, define another variable, and this variable is from 10 to 20. When I execute this code, what I'm going to get is within the workspace there are two matrices x and y. So dimensionality of both is equal, so I can create some x whole square plus y whole cube. So that is some complex, not more complex, but some expression. Now what I am going to do is when I execute this, I get the result. Sometime we write the script with 100 lines of instruction, which is very complex, and we get some error. Like if I remove this start and I get some error. So this is just a very short script, but if the script is very complex, then what you will have to do is to debug the error. You need to create a bubble over here in the first line of code, and then when you execute uh, the, the script, you will another tab will appear, and the name of that tab will be script step. So when you run this code line by line, you will see that at which line of the code there is some sort of mistake. So you will remove and debug that line of code, and then when you execute the code will completely execute. So this is very beneficial thing that you can execute the code line by line also. So now I'm going to define some trigonometric function, some mathematical expression. So I'm going to create symbols like x, y, z, etc. So these are three different symbols, and I'm going to create some trigonometric equation. 10 multiplied by uh, cos of x, cos of 2x plus 15 sine of x, sine of y, plus whole divided by tangent of x, y. So this is a very complex trigonometric function, and when I execute this, so there is something. Okay, there was a bracket missing over here. Now the expression is complete. When I execute this, I get the expression and within the workspace. When I execute the script, I get the result in the workspace. The z is equal to 10 cos of 2x plus 150. I think I have written 150 sine of y divided by tangent of xy. So when I'm going to change the expression. So it is very complex to understand this. I'm going to write pretty z. Now when I execute it, it look very good and everyone can understand this now. So this was all to create a script and write some mathematical calculation and some mathematical task within the Matlab script. So this was all related to creation, manipulation and editing within the Matlab script. You can see the script has been created. You can use it in the future. You can open it. You will see the same set of code stored within your file. You can manipulate it, you can change it, you can include some more thing within that. So you can modify and save changes within the Matlab script, and you can use it in the future. So within the next code, I will tell you how you can create functions and more complex things. So thank you so much.